In this video, we will start with revision exercise 3 of graphs and functions and coordinate geometry. You will find this on page 136 in the Namibian AS-Level Mathematics textbook Y equals mx plus c to success. Let's start with number 1. Points A and B have coordinates HH, 4H plus 6 and 5H respectively. The equation of the perpendicular bisector of AB is this. So just remember, this is the perpendicular bisector of AB. There is A and there is B. Okay. Find the value of the constant H and K. Let's start. Let's first write down the coordinate points. A, H, H. B, 4H plus 6, 5H. Okay. Now, I'm first going to find the gradient. Remember, if the gradient, this is now the gradient, AB. Now, they talk about the perpendicular bisector. Then it means it's in the middle. That's the middle, okay? And it's making an angle of 90 degrees. Okay, but let's first find just the gradient of AB. So if I'm going to find the gradient of AB, this is x1, y1, this is x2, y2. So it's going to be, I'm first going to just write it down, okay? So if I'm going to find that gradient, it's going to be y2 minus y1 over x2 minus x1. And that's going to be 5h minus h over 4h plus 6 minus h. Okay, now 5 minus h, that is 4h, it's like terms. That's 4 minus h, so it's 3h plus 6. That's in terms of h. Okay. Now, so I have now the gradient of this line. But out of this red line, this red one, I can also find the gradient. So perpendicular bisector, perpendicular bisector. And that's going to be 3x plus 2a equals k. So make h the subject of the formula. So then it's negative 3x plus k. Then I divide 2, I divide 2, I divide 2. Now I did this perpendicular bisector just to get that gradient of the red one. Do you see? This is k over 2. So I know this gradient is negative 3 over 2. So because it's perpendicular, I know that this gradient is the reciprocal, so it's positive and it's 2 over 3. Okay, so I can then say gradient, therefore, doesn't matter, gradient of AB, and that will be the remember, the reciprocal and the different signs. So it's 2 over 3. Okay. So then I'm just going to move it up. Okay. I can basically now say that this is equal to that 2 over 3 because that is also expressed in terms of h. So I can say 4h over 3h plus 6 is equal to 2 over 3. So this is going to be 12h is equal to 2, 3h plus 6. So this is going to be 12h is equal to 6h plus 12. So 12h minus 6h is equal to 12. So 6h is equal to 12. Divide 6, divide 6. So therefore, Oh, sorry, let's just get the pen correct. Therefore, h is equal to 2. Okay, so I already have h. Now, I must just go and find k. But let's just go back. I need now, because that's on that red line, I need that midpoint. Okay, and that's what now I usually don't like doing it, but just that I keep all the information and that I can see better, I'm just going to write here on this side. Okay, so I'm going to find the midpoint of AB. So I can now I have now the points. I have my point A, I have H, so it's 2, 2. And I have my point P now, so it's going to be 4 times 2, it's 8 plus 6, so it's going to be 14. And it's 5 times, and it's 10. Okay, so I can find the midpoint. Midpoint of AB. I want to move a little bit. So it's going to be, this is x1, y1, x2, y2. So this is going to be x1 plus going to be x2 divide 2, and it's going to be y2 y1 plus y2 divide 2. And that is going to be, okay, and now it's going to be 14 plus 2 divide 2, and it's going to be 2 plus 10 divide 2. And that is going to be 16 divided by 2, that's going to be 8, and 12 divided by 2, 6. Okay, so I want now, I'm the red, I want to actually find the red again. So if I have that midpoint, actually I made it blue, if I have the midpoint and I have the gradient, there is my gradient, I can basically go, I know that m, what is the gradient? I also have it there, but it's minus 3 over 2. So I can find that straight line by saying y minus y1 equals m x minus x1. Okay, so in the place of y, so it's going to be, this is x, this is y. So it's going to be y minus 6 equals negative 3 over 2 x minus 8. Now I'm going to simplify that. So y minus 6 equals, okay, now I think the best will be if I multiply this 2 on this side. Then I can have negative 3, okay, let's get the pen correct, negative 3, and I have x minus 8. And that will be 2y minus 12 equals negative 3x plus 24. Okay, and I have then 2y is equal to negative 3x. I have the 24 plus the 12, so it's 36. I just want you to go back to the question. Before, don't just go and divide by 2 on both sides. Go just back to the question. Okay. Do you see it was 3x plus 2y equals k? Okay, it was actually standing there also. That's very good. Focus there. So let's get it in that format. So I take the 3x actually then to this side. There is the 2y and there is the 36. Can you see now it's exactly the same? So then I can just, out of that, I can say then that therefore k equals 36. And that's your final answer. And that's how you do number 1. Okay. Okay, let's just make space for the second one. Not so difficult. Okay, let's just get space, 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 space. Okay. I just want to get also space here. I did a bit wider there. Okay. Sometimes just a lot of writing, but most of the time not too difficult, the methods. Okay, in this video, I forgot to tell you, you must do 1 and 2 and stop. And first write on your own, stop the video and then continue. So if you didn't do 2, you can first stop and then do 2. And as soon as you are finished, you can continue the video. Okay, number 2. Functions f and g are defined by, okay, fx equals 2x plus 5 and gx equals 8 over x minus 3. And x cannot be 3 because then it's division by 0. Okay, so let's start with the first one, number A. Now, the first one say, obtain an expression in terms of x for the inverse of f and the inverse of g, stating the value of x for which g is not defined. Okay, now let's start with this one. I'm going to make a y, 2x plus 5. Can you still remember inverse? So where I see a x, I make a, where I see a y, I make a x, and where I see a x, I make a y. Then it's x, or let's just get it correct. Then it's going to make y the subject of the formula. Then I divide 2 and I divide 2. So now, and I'm swapping the sides also. So I can just leave it like that. X minus 5, I could have actually already, you have to end by showing the inverse. Otherwise you're going to lose marks. Okay. And again, I'm going to just draw a line in between, and I'm doing that one on the side there. Okay, let's do the next one also. I think I'm just going to change colors. It will just help. It's the blue one. So y is equal to 8. Get my pen correct. 8 over x minus 3. So x is equal to 8 over y minus 3. Put it over 1. Make a bracket, I cross multiply. So 8 is equal to x, y minus 3. So 8 is equal to xy minus 3x. So xy equals 8 plus 3x. And then I divide by x, and I divide by x. So if I really want, I can write it as 8 over x plus, then it's going to be 3x over x, so the x's will cancel, so plus 3. And I say x cannot be 0. Can you remember? They said, where is it now? And where g is not defined. So you have to end with your inverse and say 8 over x plus 3, and basically just say that statement. X cannot be 0. Okay, that is your first number A. Then we continue now to number B. Okay, sketch the graph of, but now it's the fx and the inverse on the same, making the relationship between the graphs clear. Okay, so I'm going to find number B. Okay, let's start with number B. Sketch the graph of fx. Okay, let's just write it down. That's 2x plus 5. And the inverse, what is the inverse? I want to make it another color, so make it yellow. The inverse, and that is the x minus 5 over 2. On the same diagram, making the relationship between the graphs clear. Okay, now if I must sketch it, it's always a table. I'm going to use a table. But if I want to see, it's always good, positive and negative, and you can add. And maybe I think I'm going to do that approach. I'm just going to start, and I create a table. And then I start plotting, and if I see I have to add something, I'll do just to have a better picture. Because they don't tell you from where to where, so, okay. And I do the same here. And I try to avoid a little bit fractions as long as I have a few points. Actually, if it's straight lines, 2 points will give you a straight line. Okay, so you don't need so many points. You really don't need. I realized it now. Okay, so you're just going to make this x, and this is y. So let's make it -4. Okay, now let's make it -5. So if it's y equals to -5 plus 5. So it's -10 plus 5, so it's also going to be -5. Okay, as I said, you don't need actually a lot of points. I realized it now, actually previously. So 2, so it's just going to be 5. Okay, let's make it then 5. And then 2 times 5 is 10, it's 15. It's actually quite a lot. Okay, then make x, y. So if I make this one also -5, okay, and then make it 0 and 5. Okay, so if it's -5 minus another 5, then it's going to be -5. And if it's 0, okay, this one is a fraction, so it's -2.5. Could have used another one also there. So 5 minus 5 is, and this is 0. Okay. You must make 1 centimeter blocks. Don't just do it roughly. Make 1 centimeter spaces. Here's my 1 centimeter spaces to say. Okay, and now I'm just going to quickly draw my graph. Okay, now I just want to see 1, 2, and oh, this is going to be up to 15. Okay, but I just need 2 points because it's 2 straight lines. So let's go on the 2 points. But let's still number this. -1, -2, -3, -4. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4. This is -1, -2, -3. Okay, so -5 and 5. I'm in my green. So, oh, here was -5. Oh, and I didn't go up to there. -5. And then 0 and 5. So, this is going to be 0 and 5. Okay, there is my line. So, let's just take, as I said, you actually just need 2. So, I'm going to now basically ignore that one. So, I just go, there is my line. And I can even extend it. Okay, so this is fx. And this one is -5, and I'm going to extend this one. Okay, so I'm first going to write this, and then 5 and 0. So 5 and 0. And again, what I showed you there, if you have a ruler and you put it nice, then it's very nice to extend. So it's basically, you can extend it. Do you see what I mean? The same when we were doing this one, you can extend it because then you can see the picture so much better. Then you can see that it is going to be a reflection in the line y equals x. Okay, this is the line. Let's just go y equals x. So you can say, let's just get my grid away so that I'm just plain. I'm going to clean that, move up a little bit. Okay, you can just say something like, therefore, fx and f minus 1x are reflections in the line y equals x, something like that. Okay, and that's how you do that one. And then we go for the last one. Okay. Given that the equation where k is a constant has no solution, so I see it's nothing to do with this, so I think we can just clean and make space for number C. Let's see if we can fit it in here. So I can just move it a little bit like this. Okay, let's just do, this is number 2C. Now, I say if g x equals 5 minus kx. Okay, now, if I look at this one, I'm going to say, okay, where is it? I have my, okay, let me just write my original. There it is. And there it is. So I can first find, okay, let's first write fx equals 2x plus 5. And gx equals 8 over x minus 3. Okay. Now, if I want to find fg this, I'm going to take g and I substitute it in f. I take g and I substitute it in f in the place of x. There. So I'm going to have 2, and then I have 8 over x minus 3 plus 5. And that is going to be equal to 5 minus kx. Okay, so I have 16 over x minus 3. You can actually say divide 5 to, but 5 minus 5 is just going to become 0 if you take it to the other side. So it's negative kx. Okay, now I'm basically just going to multiply out so that I get an equation there. So I'm just going to put this over 1 and then cross multiply. So negative kx. Okay. X minus 3 equals 16. Okay, so if I multiply, I get negative kx squared plus 3kx equals 16. I just want to take it over to the other side. So then I have kx squared plus, no, then it's going to become minus 3kx plus 16. Okay, and now, as soon as they say has no solutions, it's going back to chapter 1, the nature of the roots. This is a quadratic equation. Now, when it's no, then the discriminant will be smaller than 0. Okay, then it's no solution. It's not cutting the x-axis, and I want to find out that values of k. So, the discriminant, can you remember? And now I have to clean all this. I thought I didn't have to clean. I had enough space. It doesn't seem to me like that. Okay, let's go back down. Okay, then basically, I'm just going to say b squared minus 4ac is smaller than 0. So, remember, that is a, that is b, that is c. So, negative 3k squared minus 4akc. So, this is going to be 9k squared minus, if you multiply that out, 64k is smaller than 0. Now, this is also going to chapter 1, and that's quadratic inequalities. Can you remember how did we solve that? Is where we go to the side and we first just going to make it an equation and a sketch. And we factorize. And we get k is 0, or 9k equals 64. So I divide 9, so k is 0. And if I 64 divide 9, I think the fraction is better here, or k is 7 and 1 over 9. Okay, so if you then go and you make a sketch of that, and you say, how will that sketch look? So that sketch will now, like something, doesn't matter, it's 0, okay, it's actually not like that, okay. That is 0, and that's 7 and 1 over 9. Now, due to that smaller, I will highlight the bottom. Okay, did you see there? So basically, I will then say, from this sketch, can you see, it's, if you think of a number line, it's an open circle because it's not the equal. I was just underlining, it's not the equal, okay. So it's that. So therefore, k is bigger than 0 and smaller than 7 and 1 over 9. And that is the value where this will have, where the value where this graph or this equation will have no solution. Okay, it will not intersect the x-axis. In the next video, I will do number 3 and number 4.